In Lesson 11.4, we're going to look at how to find the area of irregular figures and find areas of irregular figures that are graphed on the coordinate plane. An irregular figure is a figure that cannot be classified into the specific shapes that we've already studied. To find the areas of irregular figures, separate the figure into shapes of which we can find the area. The sum of the areas of each is the area of the figure. Auxiliary lines, like DE, are drawn in quadrilateral ABCD. DE and DF separate the figure into triangle ADE, triangle CDF, and rectangle, which looks like it may be a square, BEDF. And then we know how to find the area of triangles and rectangles, so no problem, just add. Here's the postulate that gives us permission to just add. The area of a region is the sum of all of its non-overlapping parts. Irregular figures are also called composite figures because the regions can be separated into smaller regions. Find the area of the figure in square feet, round to nearest tenth if necessary. It will be because we have circular parts. So we know how to find the area of a rectangle. Length times width, so 32 times 16 is 512. Area of a triangle is base times height divided by 2. So if one length is 32, the other length is 32 for that rectangle. So the base of our triangle is 32, and the height was 15 divided by 2. I'm going to cancel because I can. So what I have left is 16 times 15 is 240. Now imagine, if you will, if we took this semicircle and stuck it together with that semicircle, semicircle plus semicircle would equal circle. So I really just have one circle with radius of, okay, if the diameter is 16, the radius would equal 8. So I can do pi times 8 squared, which is going to be exactly 64 pi. But they said we could round. And so then the total area is going to be the sum of the areas of our parts, which is going to be approximately, they said round to the nearest tenth. So it's going to be 953. And 1/10, and our units were square feet. In that problem, we added to find the sum of the areas of our whole figure. Sometimes we're going to have to subtract. A rectangular rose garden is centered in a border of lawn. Find the area of the lawn around the garden in square feet. Okay, so we know the dimensions of the rose garden are 20 by 100, and it looks like we have a 25-foot strip of grass all the way around it. So that means if it goes 25 to the left, it's going to go 25 to the right. It's centered. So our length is going to be 25 plus 100 plus 25, or 150 feet. And our width, same thing. If it goes 25 down, it's going to go 25 up. So it's going to be 25 plus 20 plus 25, which would be the same as 70. We've done the hard work now, figuring out the dimensions. So we're going to find the area of the whole yard, length times width. So 150 times 70 is 10,500. And area of the rose garden, R for rose, is 100 by 20, which is just 2,000. So if we want to find just the area of the grass, we're going to take 10,500 minus 2,000. I said 1,000, I wrote 100. And so we get a difference of 8,500, and it was in square feet. You may be shocked to learn that the formula for the area of a regular polygon does not apply to an irregular polygon. That's a polygon that is not regular. To find the area of an irregular polygon on the coordinate plane, separate the polygon into known figures. I feel like that's what you're already doing. Okay, I'm not going to lie to you. The hardest part about finding the area of this is deciding where to draw your auxiliary lines to break it into figures that we know how to find the area of. Sometimes they just jump out at you, and sometimes you stare at them for a while. The magic of technology lets this one jump out at us. We could break this into, here's a triangle, here's a trapezoid, here's a triangle, here's a trapezoid. I know how to find the area of all of those things. Okay, I tried to save you the pain of watching me count squares by just labeling it on the diagram. So let's do the area of the two triangles first. Going from left to right, the first triangle has a height or altitude of 1 and a base of 4. So 4 times 1 divided by 2 is 2. And while we're using the formula, we may as well do the other triangle as well. It has a base of 9 and a height of 2, which is convenient. So the 2's cancel out, and so that's just going to be 9. Our first trapezoid had a height of 3 with bases of 4 and 5. It's not going to come out even, is it? So you have 1/2 times 3 times 9. And the other trapezoid has a height of, oh, I didn't write that on there. It must be 6 from 5, from 0 to 5 is 5. And our bases are 5 and 3. Conveniently, 5 plus 3 is 8. So 5 times 4 is 20. So now, to get our final sum, we're just going to have to add them all together. And 11 plus 13.5 plus 20 is going to be 44.5 square units. A good strategy for you to estimate the area of a closed curve, or in this case, polygon, is to count squares. Now, I did not show counting squares because that would be boring for you to watch, but it's still a good idea for you to do, especially on a test. The big idea, the area of an irregular figure is the sum of the areas of its non-overlapping parts.